Hi, Karl.
Hi, happy to be here. Are we ready to start?
Hi, Karl. How are you?
Hi, very good. Happy to be here. Hey, everyone.
Thank you for joining us. If you are ready, start your presentation.
Yes, I'm ready. Let's go ahead and get started. Okay. Hey, everyone. I'm Karl Weinmeister. I'm with Google. I'm based in Austin, Texas. I'm happy to be here at GDG Turkey today. And I want to talk about artificial intelligence. And I hope that whether you're just starting with artificial intelligence, or maybe you're a data scientist, you learned something interesting from this presentation. So I want it to be technical. I'm going to show you a little bit about the Google Cloud products and how they support TensorFlow, a machine learning framework. And then I want to show you how to use TensorFlow. And we'll actually go through a tutorial. So hopefully at the end of this, you have learned a few things, and hopefully this is helpful. So there's a few topics we're going to cover. We're basically going to walk through different ways that you can use TensorFlow on Google Cloud. So to get started, I wanted to share where we're focusing. So there is a spectrum of different tools, from very low level at the infrastructure all the way to APIs, where as a developer, you don't need to know anything about data science. You simply, let's say, pass in an image, and then you'll get labels back of what's in that image, right? Or there's a natural language API. What we're talking about today is somewhere in the middle. It's the AI platform. It's a set of tools where you can build your own custom model with your own data to solve any kind of data science problem. Let's talk briefly about TensorFlow. So TensorFlow is an open source machine learning library. It's been around for about 5 years. We recently released TensorFlow 2, which is, we think, much easier to use. I like it a lot. And now we're on version 2.3 of that. It's stable. It's a great version of TensorFlow. Let's also look at some of the other resources here. The tutorials are fantastic. There's a whole bunch of tutorials that walk you through in a hands-on way how to use TensorFlow concepts and learn about machine learning. And we'll actually use one of them today. The community is strong. You can go to the GitHub repo and see lots of different kinds of repositories, lots of great blog articles, etc. And the last thing I want to point out is that TensorFlow is more than just a library. As you see on some of the examples here on the right side, there are JavaScript libraries for doing some cool things in the browser, or the ability to do IoT type of work, working with many devices, all kinds of cool things. This is just a list of a few of the libraries that are part of TensorFlow. Okay. So let's just start out with one thing about TensorFlow Enterprise. So there's open source TensorFlow, and then TensorFlow Enterprise is a program on Google Cloud that has an optimized version of the same TensorFlow code. It's just built with optimizations and connectors to BigQuery and Google Cloud Storage, so that your experience of running TensorFlow on Google Cloud is great. The second thing is we have managed services. So we can run TensorFlow in the cloud without worrying about infrastructure, without worrying about virtual machines or Kubernetes. Now, we're going to see how you can take advantage of those things, but you don't have to. And then finally, some enterprises may want to stick with a certain version of TensorFlow, a long-term supported version. So when we mark a version as TensorFlow Enterprise, for 3 years, we take bug fixes, key patches, etc., and we put them into that version, so you can trust that it will stay. Now, we also have the latest, coolest versions always coming out, but the enterprise version is something that will last. Okay, so let's start with deep learning virtual machines. So one of the problems in the field of artificial intelligence is there are a lot of frameworks. And if you're working as part of a team, you might be working on different frameworks, different configurations. If you've used Python before, you're probably familiar with the pip installation manager. And you might find that the results you're getting are different across your team because your environments are different. So this is one of the pain points we're trying to solve here. So a deep learning VM image is an image that you can deploy to Google Compute Engine, and it has all of the frameworks, hardware support like GPUs, et cetera, all pre-configured. So you're ready to go and you don't have to worry about setting up your environment properly. AI platform notebooks are the development environment, the IDE for data scientists, basically. And they run on top of deep learning VMs. So the deep learning VM contains this environment called Jupyter Lab. And we're going to see that today, where you can create Markdown to document your model. You can create Python code, and you can share what you're doing with your team. So to create your own notebook server, it's very straightforward. And we're going to demo this. You just click a new instance and you have a set of different libraries and you choose the hardware and then you're ready to go. Okay, so now let's talk about training a model, or the process of taking your raw data and turning it into something that can predict. So we have something called AI platform training. And AI platform training allows you to submit a training job, you submit your code, and point it to your raw data. It will train in the cloud and give you a model. And maybe you tell your training code to store the model in a storage bucket so that future steps in the process can use it. And you can take advantage of some of the great hardware that we have in Google Cloud. And also, we have some neat features like something called hyperparameter tuning. So if you're trying to find the optimal parameters for your model, and there's a lot of different switches and options to get to the best, most accurate model, it can search across all of those. And so basically it makes multiple runs, each with different parameters, trying to find the highest accuracy model. Then there's a bunch of other things I could tell you about, but that's what the training service does. Now, once you have a model, how do you use it? Let's talk about AI Platform Prediction Service. So this is built on top of GKE, or Google Kubernetes Engine, and it serves your model in a REST endpoint so that you're able to use it in applications. There are also SDKs for Java, Python, and other languages so that you can reach and talk to that endpoint and pass a new data point in and get a prediction out of it. It will scale automatically. So you don't have to do this. You can do it if you want to, or it can auto scale and then scale back down to 0 if you're not predicting. So again, you don't have to worry about infrastructure. It's got things like logging and all of that set up. And you can choose what types of hardware you want to use when you version your model, if you want to use GPUs, for instance. Okay, let's now talk about what I think is a pretty cool new part of the machine learning field, which is explainable AI, which is trying to understand what's happening under the hood of your model. So here you see an example of a picture where, say you're trying to identify the picture as a dog, and you get a result back and you wonder, well, why did it select that, right? So we've gotten to the point where we can identify what part of the picture stood out and made it clear that this was the dog. Okay, and also with tabular data, with like data in your database, you can get that as well. So we're going to see an example of that in a second. How do you get explanations? Well, here we're showing the command line, but there are other ways with the SDK you can do it. And you simply point to your model and the version of that model, and then tell it which data points you want to explain. Okay, let's look at an example here. So what we're doing here is we're predicting the duration of bike rides. Okay, this is a data set that has weather and information about when the bike ride started, when it ended. Okay, and so we start with a baseline prediction. The average ride was 13 minutes. In our case, with the data we passed into the model, it was 10 minutes. Why? So here we see a list of the features in the model and how they affected the result. So you see that distance was the most important thing. Maybe we had a shorter distance than average, and so it pushed it down by 2 minutes. And the next most important thing was the starting hour. When did we leave on our bike ride? Maybe traffic was less at that time, and so it pushed it down another minute. But then you see some other factors. This is all in sort of priority order, okay? So that's explanation, something that you can do automatically on Google Cloud. Let's talk about TPUs briefly. If you have large data sets and performance is very important, sometimes training these models can take a day or days or weeks, and TPUs are specialized hardware to get to models very quickly, and they are integrated with notebooks. And then finally, let's talk about pipelines. So we talked about a series of steps. How do you make sure that the steps are followed the same every time? So we have something called Cloud AI Platform pipelines, where each step of your process, think about like DevOps, right? Applying that to machine learning, or what we call ML ops. You would want to consistently extract your data, maybe test the inputs of your data, validate them. Is the data from my data source is what I expect? Then we build a model, and then we test our model. Is it more accurate than last time? I think of it almost a bit like a continuous integration and continuous deployment process. If it is, then we push to the production server and we put it in the Cloud AI Platform Prediction Service. So a pipeline can help make that whole process from end to end reliable, a push of a button once you've coded it up. Okay, so if you want to learn more about this, let me point you to a couple resources. Here we're going to go to the CodeLabs site. It's codelabs.developers.google.com. Oops, I'm going to go full screen. And you can just go down here to machine learning, and there's as well as other subjects you're learning about today, but there's a lot of great labs here. Okay, so what we're going to do next is we're going to show a brief demo. Okay, so here we are in the TensorFlow tutorial site. Okay, so what you see here is we're going to classify images of clothing. Let's just start from the beginning. What is classification in machine learning? It means, given an item, which bucket does it fall into? And in this case, what we're given are a piece of clothing, and we're trying to figure out which one of 10 categories, t-shirt, coat, sandal, etc., is this image part of? Okay, so what I'm going to do is I'm going to be in the AI Platform Notebook service. So remember, I talked about this as one of the capabilities in AI Platform. So I have my list of my notebook servers, and all I have to do here is click Open Jupyter Lab, and then I'll be in my Jupyter environment. Okay, so let's use AI Platform Notebooks to run this demo and kind of learn a little bit about data science. So as you can see here, let's skip past this copyright stuff. A notebook contains code and it contains markdown. So if you kind of look at all of this, it's markdown. You can select whether a cell is code or markdown, and that allows you to explain what you're doing. The other cool thing is you see a number here. Each one of these cells maintains its state, and I can rerun it. So if I want to change something quickly, I don't have to compile my code. I don't have to redeploy it. I can simply change something, rerun the cell, and keep going. Okay, so I'm going to point out some of the important things. I'm not going to go through all of this in detail. Again, if you want to check it out, it's at the TensorFlow tutorials. But let's dive in a little bit. Okay, so we're in Python here. We're importing TensorFlow and a couple helper libraries. So first, we're going to import the data. So if you look here, the fashion MNIST data set. So let me take a step back. MNIST, you may see a lot in data science literature. All that is a data set of numbers from 0 to 9, and you identify it. Fashion MNIST is a fun version of that where it's based on clothes instead of numbers. That's all. And what we're doing here is we're directly importing this data set from TensorFlow, the framework. So there are a few built-in data sets where you don't have to bother going out to a database and extracting it. Just for learning and research purposes, they're already here. So what we're going to do is we're going to load the data. And the first thing you see is this split. So we have training data and testing data. Why do we have two different sets? Well, when we train a model, we want to be able to test how accurate it is. And we want to test on new data we've never seen. We don't want to test on the same things that we trained on. We want an objective evaluation. So usually you might hold out, say, 20% of the data for test. Okay, so that's what we're doing here. The other part is the labels are separated from the images. So this is how we learn. We have 60,000 images and 60,000 labels, and the labels are, shirt, shoes, etc. And we're going to learn the connection between the image and the label, and then we're going to test on the test images and check how accurate we are with the labels we're given. That's what this is. Okay, so let's keep moving. So we're going to run that cell. And then here you see the list of classes. So again, they're just so we understand it's more than just numbers here. We've created an enumeration of that. So let's take a quick look at the data. I'm going to kind of skip over this stuff. There's 60,000 images, each 28 pixels wide by 28 pixels tall. That's all. Small pictures, thumbnails. And we'll just keep going. We're just looking at the size of the data. So let's look at one of the images. Again, these are small pictures, and we can, do things like show an image in our notebook. So that's what we're doing here. And then another thing to point out, we're going to do data pre-processing. So notice that, like for grayscale images, the scale ranges from 0 to 255 of how dark the pixel is. Okay, so for neural network training, usually we want our data between 0 and 1, or maybe -1 and 1, to have a common mean and variance. And so what we're going to do is just something basic here, divide by 255, so that we're between 0 and 1. Okay. So now let's take a few looks at our data to make sure it's in the right format. So we read it in and we show the label. So here's 5 by 5, 25 of our pictures. Looks good. Now let's build a model. Okay, so we've talked about data. Now let's start moving on to actually building a model. So here you see what's called the sequential API in TensorFlow. And all that means is each layer of your neural network is defined in sequence. So the first layer is flattening. So we take our 28 by 28 images and we make them one-dimensional. So it's, 1 high and then 28 by 28 long. Okay, so that's the first layer. Then almost picture like a triangle, right, or a funnel, where the next layer is called a hidden layer because it's between the inputs and the outputs. It's in the middle. And it has 128 nodes here. And then finally, we end with 10 outputs. Why 10? because remember, we're classifying between 10 categories. And so we want our model to provide probabilities of which class we think it belongs in. Okay, that's all our model is. Now, there are much more sophisticated models out there, but often you see in this field that adds a little bit of accuracy with more complexity. You know, you can go a long ways with something as simple as this. Okay, so we defined our model. Now we're going to compile our model. And this is where we might pass in some parameters. Let's not get too caught up in this, but this tells us some things like what metrics do we want to use to provide data, as you know, what's our accuracy as we go. The other thing is what's our loss function. And what that means is we're optimizing for something. You know, if we want to figure out, are we doing better or are we doing worse? We need a mathematical function that tells us that. And so there are a few of these built-in functions. We happen to be using one that's good for this type of problem, and an optimizer. So we compile our model. We haven't actually trained it yet. And the next step, we're going to train our model. Okay, so let's go ahead and feed some data into the model and fit it. Okay, so this process may take a little while. What I'll do is I'll run, instead of 10 passes through the data, I'm just going to do 2, just to save some time. And so here you're seeing the training process, right? So it's going through the images, and then it's telling us what our loss is and our accuracy. So we were 82% correct. And then the second time around here, we'll see, I bet it will improve a little bit more as we continue to reconfigure the proper weights and biases in the model. Okay, so we got to about 86% accuracy here. All right, so if we kept doing it for longer, we get about 91%. So next, what we're going to do, now notice we were testing on our own data. Let's now check accuracy on the test set that we've never seen. So it was 85% on the test set. That's pretty good. And that's very normal that your test accuracy is less because you haven't seen this data before. All right, so now how do we use the model? So this is where we do an inference, or we make a prediction. So it's as straightforward here as we call on our model .predict, and we pass in the images. And let's see what comes back. For the first image, here's what comes back: 10 probabilities. And this is essentially telling us in a scientific notation, but you know what we see here, we want to pick the largest one. That's going to tell us the one that is the highest chance. Okay, so you know what we're doing, we're comparing what was predicted versus the actual. So yes, we weren't correct this time. And why? Because I didn't train it for 10 passes through the data. My model still could be more accurate as I learned more, but I'm just trained to kind of fit within our 25 minutes. So let's now plot some of the images and kind of compare them. All right, so here's an example of that test image. Here's what was passed in, and then you see the probabilities. And again, we were wrong on this first one where we thought it was a sandal and really it was a boot. But you see that it was with 59%. And then the second most confident answer was correct, which was that it is an ankle boot. Okay, and then there was a third thing passed in there. And then you know, so then we can do that as well. So if we kind of go through, I'll just keep moving here. We'll go through those original, let's go through 15 different images and compare what was passed in and then what category and probability we expected. And that's it. Okay, so let's show again how we can use it on a single image. We'll just kind of walk through it. And you see here, all we're doing again is calling .predict on the image. And then here, we have a function to graph those probabilities. Okay, and in this case, we got it correct. So, so that's TensorFlow in the cloud. I think we are at time, and I will stop presenting. Thank you, everyone.
Thank you, Karl. Thank you again for supporting us. We have some questions. I want to ask you.
Sure.
Could programming TensorFlow with Arduino provide enough intelligence for machine learning? Repeat after me.
Yeah, I see the question. I think that yes, you could learn quite a bit from programming with Arduino. TensorFlow has support for that, and there are so many cool demos of like detecting, like, say, items where people might say, hold up, here's my AirPods, and detect it, and they're using the camera, they're doing it on Arduino. So yes, please, love to see more demos on that. Very cool. What other questions?
Okay, thank you. Murat Tatar asks, what do you think about NVIDIA Jetson?
I'm not familiar with NVIDIA Jetson. Do you know the name of the chip, like the code name? Is it A100 or is that a different one? Sorry. If it is A100, that's a great chip that Google Cloud will be adding support for. You can see a blog post about it. I'm really excited about it. Hope that's Jetson that you're talking about.
Okay. Hope to see you again at another event.
Sounds good. Thank you. Thanks for having me.
Thank you.
Bye, everyone.
Bye.